Good evening, everybody. Good to see the awesome CSNP community again. Thanks for joining us this evening. And special shout outs to Tony Diaz for stopping by to set things up. Huge help, Tony. Appreciate it. Okay, people, we've got a special presentation tonight. That's the sequel to my own presentation from a little whiles back, which was how to set up your own home cyber range. So today is all about, well, how do I take the first step in using these tools and using them meaningfully and starting to do things like network traffic analysis, for example, to start building our skills and practicing. So both Javon and I are Code Fellows instructors. And so I can definitely vouch for Javon's ability to level up people who are looking to get into this space. He's done a fantastic job with our Knights cohort here at Code Fellows with our remote instruction program. So I'm very excited to introduce Javon tonight, and I'm very much looking forward to this presentation about network traffic analysis. And be sure to join us tomorrow as well. We've got a presentation on ethical hacking test taking on if you're trying to pass that CEH, be sure to check that out. If this is your first time, welcome. This is our CSNP Wednesday webinar. We try to have these every few weeks to get you some free education and exposure to the cyber community. And that's the core mission of Cybersecurity Nonprofit. You can always follow us on csnp.org. And we're also on LinkedIn, Twitter, all those platforms. So without further ado, I say, Javon, if you're ready, I'll turn it over to you and have you get started.
Excellent. Thank you, David, and thank you, Tony. Yeah, I was on mute for a second there, of course. So is my screen coming in good?
Yeah.
Cool.
Yep.
Thanks. Yeah, I'm excited to be here and have the opportunity to talk about this. I enjoy learning and I enjoy teaching, especially about this material. Which is why as long as I get the opportunity, I'll continue to do it over and over. And there's no shortage of knowledge in this industry. That's something that anybody could tell you spending, I don't know, 5 minutes learning anything about this this type of stuff here. So yeah, as David said, I'm gonna give a sort of a high level, but not too high of a level overview of Wireshark and some of the things you can do as far as network traffic analysis with it. And I'm going to give you all a scenario to consider during a demo later on in this presentation also. So yeah, I'll break it down and tell you a little bit about myself, why even use Wireshark for network or traffic analysis or many of the things that it can do. What is it? And then what are some of the things that you can do with it? So about myself, as David mentioned, I am the nighttime and weekend instructor for our cyber ops curriculum at Code Fellows. In my daytime job, I am a cybersecurity specialist, and I use that term quite broadly because my scope of work has ranged to many things over my career thus far, from dev to systems administration to infrastructure operations to writing requirements, ton of documentations, government type of work, all kinds of stuff. I enjoy doing the world of IT and cybersecurity as a whole, which is why I spend my time outside of work doing side projects, learning new things. There's no way I can know everything, but I do try. I do try. Lifelong learner. I have several mentors, industry experts at my company, outside of my company, individuals that I've met that have helped me get to the point to where I am today. And any of them will tell you to just always keep learning, stay hungry, be curious constantly. Eventually, you'll find your niche and something that you enjoy so much that you'll just want to keep doing it, and potentially even sharing it with others, helping others learn about it as well. My background is really in systems administration. I started my undergraduate at UW at their IT program. I probably would say the first opportunity to where things really clicked for me was getting involved with Linux, Ubuntu, and Fedora. It's where things just kind of started to click one day, because I was like a lost child early on getting into IT. I was talking to my advisor one day and trying to declare a major, and they asked me, "Well, what do you like? What do you like to do?" I said, "I like video games." Like, you should try the IT program. It's like, sure enough, little did I know that it was not a cakewalk, not at all. So, but if you do enjoy IT and cybersecurity, definitely keep pushing. You'll eventually get there. I have a master's degree in cybersecurity from DePaul, and the concentration in that is in networking infrastructure. I highly recommend that program. The course catalog is very extensive, and there's a lot of opportunity to do hands-on projects, work in assignments, which is how I learned personally, by doing. So all right. So Wireshark. If nobody's heard of Wireshark before, at its core, it is a protocol analyzer. I'll use that term there. But why Wireshark? Well, why should you care to analyze things on your network or any network? Well, everybody pretty much uses network services in their everyday life, whether it's at home, whether it's at school, whether it's at their job, or wherever they are, on your mobile devices, your phones, your gaming consoles, your computers, your workstations at work, your personal computing devices, more, and even more. There's even IoT devices, your fridge. All these things now are using network related resources. So we know now, okay, so pretty much everybody is using network resources. And why is that important? Well, if everybody is using it, well, I like to use this analogy kind of like, so everybody drives a car too, right? Everybody drives a car. Well, cars need maintenance. Cars get problems. Cars, they have to get fixed when things go wrong. If you don't know how to fix them yourself, you're going to pay a professional or somebody else to do it for you. Well, learning about cars, I don't know a lot about cars. I tell people this all the time when I tell them, yeah, I work in cybersecurity and IT, but I say, well, everybody uses networking devices, so you should learn how networks work and be able to, at a basic level, understand what's going on. Yet I really don't know how to work on my own car. So kind of being a little bit hypocrite there, but that's the idea that I'm kind of trying to explain here. So when I say CIA here, I'm talking about confidentiality, integrity, and availability. So these are core concepts in information security that exist to ensure confidentiality, integrity, and availability of data. It could be at rest or over a network. So you all have internet at home, I'm assuming, or most of you do, or wherever you are, you have sensitive data that's going in and out of your devices. Well, how can you ensure that that information is not being disclosed to individuals that shouldn't have it? How do you know it hasn't been altered? How can you ensure that the network services for your devices will be available to you when you need them? Well, if you don't know how to do that, or if you don't understand that at some level, you're going to rely on somebody else to do that for you. That's not necessarily a bad thing, because there are very smart people out there, and there are really great products out there that will help aid in protecting some of your data. But if you know absolutely nothing, if something goes wrong, or, God forbid, you are the victim of a cybersecurity attack, you're going to be relying on somebody else who knows what's going on. But there is a lot of information and a lot of resources out there that are free, like Wireshark, that people can use and learn about to help better equip themselves to really know what's going on in this world of cyberspace. Because if you look at the news, it's almost like every other month, somebody or some company is a victim of some cybercrime. So I dare say that it's a matter of when and not if any one of us could be a victim of some kind of cybercrime. So Wireshark, really good platform to get your feet wet in, which I'll demo today. Like I said here, a lot of the cybercrime and a lot of the biggest ones that are occurring over the news lately happen over networks, especially over remote networks. So what does that mean? That means that, let's say you have a big corporate network with, 1,000 PCs and servers, a couple hundred employees. You pretty much have your own internal internet within that network. Bad guys are able to infiltrate that network, and a lot of the time go undetected, because it's so large and there are so many entry points in there. So it's easier for bad guys to infiltrate and navigate larger networks, because there's a larger attack surface. It's kind of the rule of thumb is the more you have, the larger the attack surface is. More fancy features you have, you're usually introducing potentially more vulnerabilities. And if you would have guessed up to this point, understanding how a network works and being able to read internet traffic or network traffic is an extremely valuable skill. Many certifications, professional certifications, whether it's cybersecurity or a general type of IT certification, are going to require that you understand how a network works, and really how to read simple packet captures as well. So like I mentioned in the previous slide, Wireshark essentially is a protocol analyzer, but it does much more than that. Protocol analyzer, packet analyzer, they can either be used synonymously. It's going to help you analyze network traffic. So I have a word here. It's actually an acronym, TAP, Terminal Access Point. And I put here, so I found this image online where it's a pretty good representation of what that TAP is. So if you've ever heard of, like in movies or shows, like we have a wiretap on the phone or something like that, this could be what they're talking about. This device right here acts as a network tap. Here you have a connection here. Here you have the network switch connected to the wiretap, and then the monitoring computer where you're actually going to capture the data for the network. So essentially, traffic destined for this network, you'll be able to see and capture with this network tap. Now, this is hardware There are also software versions of this as well, which I'll be using for the demo. But the hardware network taps are going to give you a little bit more beef in that there is a smaller chance that you will miss packets as opposed to software. So yeah, I wanted to show that. And then let's go back to the presentation. And the Wireshark that I'll be showing you is going to be the GUI, the graphical user interface. There is a command line version called Tshark as well, for those of you who prefer command line utilities versus graphical ones. So this image here basically is really similar to the one that I just showed you, where, all right, here's the internet. If you're going to use Wireshark, here's the internet, here's a router, assuming that there's a given network back here with a switch. Here is a computer running Wireshark with a network tap. Here's another host on your network, which when you start a packet capture, will be able to capture the network or the traffic within this network or destined for the network from this host over here, or if there are 100 on here potentially, it should be able to see that traffic. And there's all kinds of traffic within a Wireshark packet capture. So later on, I'll kind of show you how to filter out some of the noise, because if you are unfamiliar with some of the, I guess you could say, essential networking protocols and really units to look at, you can get kind of lost in the sauce. So I mentioned a little bit before what it can do. It can do a lot more than just look at traffic destined for a network. It can help you troubleshoot network problems if you are able to recognize what a denial of service or distributed denial of service attack looks like. It will display that as well. If malicious data is being sent over the network, it can potentially help you see that as well. Identify unusual, notorious hosts, all kinds of stuff. So I got this image right here. It's like it's a multi-tool, because essentially that's what you can do. You can look at traffic for wireless cell phone traffic, Wi-Fi. What else? There are a lot of different things you can do with Wireshark, but of course, in order to be able to analyze things like cell phone traffic, even GPS related traffic, you need the hardware to match with it, because Wireshark is just the software. It's going to require the hardware in order for you to do some of those wireless type activities. But detecting denial of service attacks, seeing malicious data, identifying weird hosts on your network, you don't need anything special for that, just a little bit of know-how. And of course, monitor network bandwidth utilization. I've lived with roommates before several times throughout my life, and some people like to play games or stream movies, right? That ever happened where you're there and you're wondering why you can't download something or stream something because it's going so slow and you have no idea who's doing it? Pop open a Wireshark packet capture, find out who's hogging up all the network resources. So lots of different use cases for Wireshark here. So I put this image right here. It's kind of like an onion, or like the image I was trying to portray is that there's layers. When you're thinking and talking network, you have to understand that it really operates as like a layered structure. So if you're unfamiliar with the TCP/IP or the OSI model, I'll try to kind of allude to that briefly. So when we take a look into Wireshark, at the lowest level, you're going to have frames. Frames are a unit of data that are going to be shared between the link layer, which is the physical layer really of the OSI model. So essentially, it's the lowest layer of this stack that I'm showing you. And then at the next layer, you have Ethernet, to where you have associated MAC addresses. If you're unfamiliar with MAC addresses, they are essentially hardware addresses in hex format, 48-bit address. At the layer above that, hopefully many of you are familiar with IP, Internet Protocol. That's the next layer up. And then above that, you have the TCP, UDP, and you have other protocols at these layers, but these are the primary ones that I'm going to focus on. TCP, UDP for transportation. And at the top layer, you have data. Now that could be these are your applications of the internet. So you have TCP port 22, 23, or your HTTP, HTTPS, SMTP. That is the really final layer if there isn't additional data to follow that. So when frames are coming into Wireshark, it captures frames, and then within frames are Ethernet data, IP data, TCP, UDP data, and then the data on top of that. So each layer is being unpacked as it comes into Wireshark, and we'll take a look at that later on. But just trying to portray the layered aspect that is here, because at each of these different layers, different things are happening. And there are cybersecurity implications at each layer as well. I'll be focusing on one particular layer, and it'll be at the upper layer up here, up at the data layer. But I will kind of give like a, hey, here's what I was talking about earlier when I go through the demo to help visualize these layers here. So the scenario that I planned to share with you all so one day somebody, you, your friend, whoever, they're on a public Wi-Fi, Starbucks, the hotel, wherever, a public Wi-Fi that anybody can connect to. It's not private, which means that you're in a shared network with other individuals, a shared untrusted network, meaning that the information on that network, you cannot verify that it is safe because you don't know who is on there and what is being done. As opposed to your home network, you essentially should know who's connected to your home network on what devices, and you should have some kind of ability to manage the access to your network. And like I was mentioning before, if you don't have that just kind of basic layer of administration knowledge about, all right, who's connected to my network? What are they connected with? So I'm talking about viewing like administrative pages for your network if you have like a routing device or something. If you're not familiar with that, if something goes wrong, you're unsure, you're probably going to rely on somebody else who knows what they're doing. So it's always good that if you're unsure or if you want to know about something, to go and learn about it or go and try it yourself. It's the best way that you're going to learn. But back to our scenario. So you're connected to a public Wi-Fi. Assume that you're this laptop over here, and the other people on this network, this right here, the skull with the ear right here, these are individuals on the network who could be potentially looking to, do some malicious activity. So they're listening on this network. They're looking for vulnerabilities. They're looking for devices. They're scanning the network. They're probing to try and see what they can see. And if there's anybody that's gullible potentially, or has vulnerabilities on their device, or if there are really no protections on the public network to help defend you against these people, that's what the bad guys are counting on. And this is not a far-fetched scenario at all. So you're connected to public Wi-Fi, and you are going to browse LinkedIn because you just got, you're trying to look for a job, right? Or you're trying to look for a better job. You're trying to connect with some recruiter or a hiring manager, which I'm sure if you've all used LinkedIn, you've had InMail or you've had some conversations and viewed feeds on there. So the scenario is you're going to LinkedIn to look for some stuff. So now we can get to the demo portion. I'm going to pull this up. So for those of you who are interested, I'm using VirtualBox as my hypervisor to house the VMs for the scenario, running Windows 10 VM and a Kali Linux VM. No really special configurations going on. There's no there's no special configurations going on here, just simple deployments to help with this demo, just kind of background stuff there. So if this is your computer here, this screen that I'm on right now, you go to check your email. You get an email. Please verify your identity. Please verify your identity to access your profile here, and you get a hyperlink to click. Thanks, account support team. So everybody who has email has probably gotten spam email before. Spam filters have gotten really good over time at filtering a lot of the noise, but they don't catch everything. And the bad guys, they will tailor email messages to individuals to make it seem as though they're legitimate, right? Because if you're a bad guy and you want to carry out a successful attack, well, you have to convince your victim that you're not a bad guy. So that can be done by crafting specific email messages with malicious links in them, among many other ways. So that's sort of what I've done here. So, you click on this link. You should be smart enough also to know that, hey, if you've got a weird email, you probably shouldn't click on links, but not everybody realizes that. And sometimes people click on links. So you get this email, you click on this link right here. So what I'll do, so I'll also show you the view of the bad guy. So the bad guy is going to run SE Toolkit. It's going to pop up a fake LinkedIn site to make it appear like it's the actual LinkedIn login screen. And if you have ever used Kali Linux or anything like that, SE Toolkit comes out of the box with any of them. It can be ran with, you can just run SE Toolkit. I'll give it to you there. So your bad guy that's on the same network you are, he's going to create a fake site of LinkedIn and try to get you to go to it to steal your login credentials. LinkedIn.com. So this is essentially, it's going to go and make a request to LinkedIn, grab the HTML data and clone it to a fake site, which we are going to direct to the victim. So now the victim is waiting at this link over here, which, or the attacker has created a kind of a trap for the victim to click on, which is this link right here, which they click on. Oh, it's linked.com. Well, let me redo that just so, because I must have done a typo. So we want linkedin.com, not linked.com. And I did think about just kind of doing this all kind of transparently, but I wanted to show just how simple it is to do something like this. LinkedIn.com. Okay, now that it's running, let's go back to our email, click here. So essentially what this link is it is a link to the attacker machine that is hosting the fake site. Just to reiterate that again. Should pop up and show this right here, LinkedIn, login page. So say you log in, your name is like fredjones@gmail.com. You enter your password. Click sign in. It's like, okay, well, that was a little weird. Why didn't it just log me in? So you go to sign in, you go to log in again, but you really think that was weird that it's making you sign in again. So you have the opportunity to go and view the traffic that was associated with that request and response that you just had. So if you were going to go and analyze what just happened there, what you would do, you'd pop open Wireshark. So before I continue the scenario, I'm going to give kind of the basic navigation around Wireshark. So essentially, you have to select a network interface where Wireshark is going to put that tap in to listen to the network. So if you have multiple networks that your PC is connected to, multiple interfaces, you'll need to select the right one to capture the right traffic. And this little pulse right here, this is showing you that it is receiving traffic, that there's traffic for it to capture. And this is the correct one that I want. So you start capturing traffic. Okay, traffic's capturing. Go back, click your link. Log in again. Yeah, it does that weird thing again. You're just not quite sure about. So now, get out of the way. You stop the capture. Okay, so let's talk about the interface here. So like I was saying before, if you're not familiar with kind of basic networking protocol services, it's easy to get lost in the sauce here. So one of the first things you really want to do when you are doing packet capturing is you want to really know what you're looking for, or at least understand enough to what you're looking for to apply to these display filters up here. So what do I mean by that? Okay, so if you are trying to analyze traffic, one of the first things you should probably know is your own IP address to know the requests being sent from your machine and the responses being sent back. So I know that the IP address of this machine is 10.028. Okay, so what you would do is you go up here and you type IP ADDR equals, and then the IP address. That will filter out each of these frames here for this IP address. So back to the interface here. So you have number of frames here starting with 1 up to however many your packet capture has. You can let this thing run for a really long time, and these files can get really big. There's a timestamp associated with each frame, a source, and a destination. So a source where the request came from, and the destination where it was going to. The protocol, like I was mentioning before, those layers, we have TCP right here, the length, and then additional information according to the protocol. So if you're unfamiliar with TCP, it's transport control protocol. It essentially guarantees the transmission of data by way of a 3-way handshake over a network, where it says pretty much, hi. The receiver says, okay, I got your hello. The other one says is, all right, and I acknowledge that also. So when you have a 3-way handshake, the connection is established. Just in a nutshell there. So when I was talking about the capabilities, take a look here, telephony, right? So if you have the right hardware, you can capture all kinds of network traffic. Just with a click of a button. You probably should read, some user guides and ensure that you know what you're doing. But Wireshark has the capability to do a lot of different things, Bluetooth included. For capturing wireless traffic, I've done that before. It's not too difficult. You really would just need a wireless network adapter. They usually come in USBs. Just plug it in. It's got a little antenna. If you have one of those, Wireshark will recognize that as an interface and listen for traffic coming in and out of that as well. So I'm definitely not going to have the time to cover everything within Wireshark in this menu, but I will show a couple of things. So the statistics are going to be something really important as well. So like filters as well. If you are not using the filter and you want to just look at the statistics, you can go to source and destination addresses. And what am I, 10.028 here, right here? Here are the statistics associated with that IP address here, just to help, your understanding of everything's going on. Because look at all of these IP addresses. A lot of these potentially you don't need to care about based on the scenario that we're going through right now. So now let's take a look at this down here. So back to my drawing, it's talking about these right here, frame, Ethernet, IP, TCP, and then the data. So we have frame here, Ethernet with a source MAC address and the destination MAC address, IP, TCP, and then HTTP with data embedded. So if you unpack these with a filter, the little arrow here, you can see some of the information that is associated with each of the protocol units up here. Now, a lot of these, there definitely is important information in some of these, depending on what you're trying to do. It's like I mentioned before, if you're doing network analysis for Wireshark, really need to know why you're doing it, what you're doing, because again, there's a lot of noise in here. But our scenario, we're concerned about that login page that kind of didn't take us to where we wanted to go after we logged in. So that's what we want to look at now. So we know that the victim machine is 10.029. So when you go to web pages on the internet, you send requests out for resources. So if you're going to linkedin.com, you send a request through other networking devices to get LinkedIn.com returned back to you. So you want to start with, okay, the source is you. All right, so the next thing that you may want to do is like, okay, I know my IP address. What is the IP address of LinkedIn? Because that's where I wanted to go to. So how could you find that out? Well, you could ping LinkedIn.com. It looks like it could be at 13.107.42.14. Let's put that in. 13.107. 42.14. Wow. 10.107. Oh, it's 13. 13. Typos. There we go. Okay, so we do have some traffic here destined for LinkedIn, it looks like. But most websites, especially LinkedIn these days, are using HTTPS and have secure communication with encrypted channels with TCP. Well, if you don't know that, you do now. So up here, HTTPS, that is port 443. This is secure HTTPS. Its purpose is to hide the data that you're trying to access so that bad guys cannot see it over the network. Well, let's go back to this link here. Not secure. And this is not the IP address of LinkedIn either. And it does not say HTTPS. This page is HTTP. So we know that things need to be looked at further. We have an address up here, 10.0.2.9. That address is pretty fishy. So let's go ahead and filter that. 10.0.2.9. Okay, we can see that there are repeated requests out to 10.0.2.9 and responses. Based on this, you can assume that 10.0.2.9 is going to be on the same public network that you're on. But what reason would you have to connect to 10.0.2.9 if you're trying to go to LinkedIn? Unless somebody was actually hosting a web server on the public network, which is extremely unlikely. So what I'm talking about here are indicators of compromise. These are things that seem fishy, things that need to be investigated because they often can be associated with malicious activity. So you can see that there is a bunch of traffic here that is HTTP and is unsecured between you and this other host, which is the attacker machine. Now, like I said before, there is a lot of noise in here, and the actual raw data, I forgot to mention, is displayed down here. So, and then it's parsed over here to the right in sort of a human readable format. So the raw data here they're hex bytes really, and then it has a human readable format over here. There's a bunch of stuff over here. It's got like it's got information about stuff that you definitely aren't familiar with. So you can definitely assume that something weird is going on. Traffic's being forwarded and continued. There are links in here. Oh, and look at this. So once you go to LinkedIn, the actual LinkedIn.com, this may be an indication that the fake LinkedIn.com, once you put in your information, it was forwarded to the real LinkedIn, because if you're a bad guy, you want to make it seem like, you didn't just try to do something fishy to somebody. So I'm going to jump over to the attacker machine. And while this was over here running, the attacker got some information from you. So, oops. So normally generates a nice HTML report. Apparently I didn't turn that on this time, but once you entered your information in here, this was able to capture it. Now I need to find, okay, here, I found it. So here, it picked up the login parameter for fredjones.com and then your password that you entered for LinkedIn. Now, a lot of this, for this simple demo to work, there's some weak assumptions with the security controls for the public Wi-Fi and even potentially your own device as well. But that's not to say that this still cannot happen and it's not feasible, because it definitely is. And people definitely fall victim to stuff like this. It doesn't take very much to be able to carry this out. But in the victim machine, that activity where you just went to log into LinkedIn and then the page just went away real quick, all kinds of stuff was just happening. This Wireshark capture enabled you to see that, well, you weren't actually going to LinkedIn. You were actually connecting to some weird guy on the same network who was intercepting your request to LinkedIn and gave you a fake login page, really because you clicked on this link in your email, which he found out what your email was somehow. But when you're a bad guy, if you're really good at what you do, like you're a cyber criminal, you do a lot of research, a lot of background to ensure that your attacks have high rates of success. So you found out who the guy was, found out his email, you craft an email message, you put a link in there, and then you waited for him to log in, take his login information. But you were able to see that just happened in Wireshark. Now you can start to, hey, reach out to the administrator or whatever it is you need to do and say that you've got some stuff you need to do as far as investigations of this network, because I think that you have some hackers in here. So that's really the end of the demo that I wanted to show you for this scenario. Again, there is a ton of information, additional information in Wireshark to help you dig even deeper to figure out what is happening. But I think that I was able to touch on enough to give you an idea. But you have to really understand some of the basics of networking to really understand what's going on here, how requests out for resources to the internet work, and then responses back. So you can see here, this is really HTTP traffic destined for port 80. If you get rid of this, you've got all kinds of other stuff in here too. TLS 1.2, this is going to be secure connection. So the actual LinkedIn should appear as TLS, and it should be encrypted traffic. You shouldn't see any of the green in here for HTTP traffic. That's going to be a big red flag for most things you're going to be looking at on the internet. And you've got here all the DNS stuff as well for name services, all of the stuff that's happening over the network, not all of it, but a good bit of it is going to be able to be captured in Wireshark. Okay, so back to the presentation here, which I closed. Ta-da. Okay, so that concludes my presentation. Thank you all for listening to my explanation and my scenario. Again, this stuff is really fun, and there's a lot of stuff that you can do here. This was just something that was Really simple to do, but if you are interested in yourself, I highly recommend just trying something like this out. There are a lot of resources on the internet out there that can help guide you through an example like this.
Yeah,
So
this
yeah,
was fantastic, Javon. Thank you for presenting this. I've seen this before, and this presentation never gets old. It's always equally terrifying to see that kind of deception. Excellent. So we've got a few questions, and I want to go ahead and see if do you have a few minutes to answer them?
yeah, sure. So
Uh, the biggest one I saw earlier was how does somebody like get project experience in the security space? Where do you recommend they plug in and get started?
anything where you can get your hands on working with live machines or something like that. So like Hack the Box, um, any type of cyber competitions out there, because you might feel like that's like a bit overwhelming, but there are plenty of cyber competitions and challenges out there for all levels, knowledge levels, from experts to beginners. Once you get your feet wet in these, not only do you gain experience, but you also can potentially increase your network of other individuals. Networking is extremely important skill to have.
Okay, what else here? Brian is asking, can you recommend any resources to learn more about Wireshark specifically?
Their documentation is pretty solid. Um, you can you can always hit up Google. That's what I do for 99% of anything that I need to know is I ask Google. Wireshark is free for anybody to download, and for something like Kali Linux, it comes out of the box already. Um, yeah, and hopefully, I mean, this video is available to you. This could be potentially a good starting point. Just opening up Wireshark and starting a packet capture on your own home network to see what's going on. Go to a website and see if you can find in your packet capture where you actually requested to go to that website.
Excellent. Another question was a question that I get asked in an interview was, what would you do if you had an internal server sending ping packets at a frequent rate to an AWS machine? You then inspect the packets and see a equals sign. What does that tell you, and how do you respond to that?
So you have an internal server sending ping requests to an AWS machine. So is your internal server not in AWS? That would be like a follow-up question.
Yeah, that seems like quite a technical question. I know that the equals is a way you can, I believe you can filter with that in Wireshark. Um, I
Yeah,
definitely would want to clarify that.
yeah. So when you see equals, that's in a packet. I'm not sure I've seen equals, but I know you would use that if you were filtering to look through packets. Um,
Right. That's what I was thinking.
but your big red flag is going to be why your internal server is sending ping requests to AWS if it's not an AWS and a part of the infrastructure. So that's a if that's happening there, that's a one can of worms. And then what you're seeing in the packet capture after that is another.
Oh, I see a chat about malwaretrafficanalysis.net. I highly recommend that site. There are some excellent traffic analysis exercises with Wireshark.
Okay, cool.
On that site. It's so great. I've even worked it into our Code Fellows curriculum for 401. It's that good. It's also totally free. It's great stuff. It's just a matter of finding that data dump and using it effectively to learn is the big challenge.
Yeah.
A couple more questions. Oh, go for it, Javon.
I was going to say, I completely forgot to mention that. Yeah, if some certification exams, and if you are in some program at some school, they will give you a malicious packet capture that you have to analyze and figure out what's happening. If there's a DDoS happening or if there's something happening. So yeah, that's a good recommendation.
Yeah, follow up on that last question. Apparently, the interviewer said that equals was an indicator that it was malicious, and they were just asking how to remediate that. But I've never heard of a ping packet doing that. Maybe they're just hinting at packet crafting, like some kind of malformed packet being sent out.
Mm-hmm. And
So.
yeah, that could be true. Wireshark actually, out of the box, it has the ability to detect some type of attacks. Like if you were doing like TCP reassembling to try to craft like an attack, Wireshark would capture that. It would say this was reassembled another time, and this is weird. So it's not something that I demoed, but maybe that's what they're talking about. Wireshark does have the ability to call out some of that stuff, but I can't say that I've seen equals before in an actual packet.
Yeah, that's a very odd interview question. I agree. I haven't quite heard of that one. Do you recommend any YouTube channels that are good for more Wireshark lessons like this one?
I cannot say that I've spent a lot of time on YouTube looking at Wireshark, but YouTube is a great resource. Usually I am on Twitter following really smart people doing this stuff because they do it in their sleep and they make it seem so easy. That's usually where I go to look at things. But YouTube is great for many things though. Yeah.
Do you mind if we share your LinkedIn, Javon, if people want to follow up with you about this stuff?
Yeah, sure. That's all good.
Great. I'll go ahead and post it here in the chat. Okay, and let's see. Yes, another puzzled question about the equals. I would suspect that's not so entry level. That's a pretty specialized question.
I've had a lot of interviews in my time, and very few entry level interviews are asking you about Wireshark capture data that I've had. That's not to say that they won't. I'm just talking about my experience, because if I was an interviewer and an employer, I'm probably not going to ask an entry level applicant about Wireshark packet captures.
Right. They tend to quiz you on fundamentals like, do you understand what a packet is? Do you understand the OSI model? Things like that. So yeah, if you're applying to these jobs, get your fundamentals down. Don't be obsessed with the tooling. Be obsessed with, why am I using the tooling? That's where you want to be, is my advice there. Oh, looks like somebody says the promo code I posted is invalid. Oof, that's not good. Let me try another code here. Give me 1 second, folks. That's a big, ugly link, but give that a try. And if you're having problems validating that thing, be sure to add me on LinkedIn and reach out to me directly, and I can definitely help you with that. Anyways, I just posted that, and I wanted to just share with y'all, there's been an unprecedented rise in cyber attacks. We were seeing a plus 600% increase in the last few months. And honestly, there's never been such a high demand for professional, skilled hackers who can learn these systems. And so we have a workshop this Sunday, and we run these every few weeks or so. And we introduce you to what is ethical hacking and what are some cybersecurity career paths that you can pursue. And so I encourage you to check that out. We're projecting that this year there's about 3.5 million unfilled cyber jobs worldwide. So we really need people like yourselves from all walks of life to join this community and really help us innovate cybersecurity into the future, into the near future here. This is a serious need right now in the tech space, and the jobs are definitely reflecting that demand, I would say.
Oh yeah.
So, yeah, Javon, do you have any any closing thoughts, maybe on careers about this before we wrap up here?
Sure. Yeah. Yeah. Don't, if you're curious or you're interested in this, yes, it can be nerve-wracking and overwhelming. But I've only been in the industry a few years, and I still feel like I know nothing. People have been in the industry for 20 years. Nobody can know everything, but there's opportunity to constantly learn. My background is not in IT. I got into IT from health and fitness. I was going to be a personal trainer. I just decided that, hey, I think computers are cool. So, but I had to learn from nothing, build from nothing pretty much up into where I am today. But it was my curiosity in and outside of the classroom that brought me here. So if you're determined and you have interest to do this, not just for necessarily a paycheck, the the opportunity is out there. Like he's saying, there is a shortage on qualified individuals for this industry right now. I I've, I can see it. I can see it, and I see it all the time.
Excellent. Yeah, and I noticed some of you were surprised that this is a live demonstration, and we really believe at Code Fellows, particularly in live instruction over virtual sessions, and we strictly teach live demonstrations. We don't have pre-recorded videos, tapes, or anything like that. We have in-person lectures plus demonstrations, and we support you throughout the challenging learning process of becoming a cyber professional. That's a tall mountain to climb, but we believe it's very much possible. And so, yeah, Javon, this was your debut with CSNP. I hope you had a good time. I see there's always more questions rolling in, but I'd like to wrap things up and make sure you get to enjoy your evening. Javon teaches our nights track of the Cyber Ops program over at Code Fellows. And so I wanted to thank you, Javon, for popping in today. It was an awesome demo. And
Yeah, thanks.
and shout outs to everybody for joining us tonight. It's always great to see and talk to you all with the CSMP community. And be sure to join us, talk to us over Slack. Check out follow us on LinkedIn. You can connect with me to keep up with upcoming events with CSNP. I volunteer for this org to make sure we promote this idea of accessible education and training for everybody. So this is something we definitely believe in. Thanks, everybody. I hope you had a good time. And that's a wrap. Have a good evening. And we'll see you next time on the CSNP Wednesday webinar. Have a good evening, folks.
See ya.